Hi everybody. I'm going to try this again. I'm going to try to present the next lesson, which is Law of Signs Application Notes. That's the next notes in your packet. So I thought you might want to start with a thought of the day, like I have when you walk into my class at school. So here's a thought of the day that I found. In a world where you can be anything, be kind. It's a quote from Mother Teresa. So welcome to my dining room. This is my china cabinet, and my husband figured out a way using actually wooden spoons to get this whiteboard up here so that I can write on it and erase and it wouldn't move. So here you go. We're going to try this. So if you can find your notes on Law of Sign Application Notes, what I'm going to try to do is lay out the questions and then have you refer to the notes that I uploaded onto Schoology to fill in the math behind it. Okay, so for the first question, a forest ranger at an observation point A along a straight road sights a fire in the direction of 32 degrees east of north. Well, you know, just prerequisite information that you have to have is your directions. So remember that if this is due north, south, west, and east. So, a forest ranger at an observation point A along a straight road sights a fire in the direction of 32 degrees east of north. So, I'm going to try my best to do a good drawing. So you have this forest ranger on a straight road, and we're going to say this is our forest ranger A, sights a fire. Let's say that this point up here, we'll call this F, is our fire, and it's 32 degrees east of north. So if you went straight north from this point, and then went east 32 degrees to the fire, this is due north, this is 32 degrees east of due north. So then we can find this angle in here. So to be 90 degrees minus 32 degrees. So this angle right in here is going to be a 58 degree angle. Another ranger at observation point B, 10 miles due east of A on the road. So here is A, 10 miles due east. We have observation point B, sights the same fire 48 degrees west of north. So if this is north, and he sights the fire, which is over here, it's 48 degrees west of north. The 48 degree angle would be right here. And then if you do your right angle, 90 minus 48, this would be a 42 degree angle. There's 180 degrees in a triangle, 180 minus 58 minus 42. The angle up here at the fire would be an 80 degree angle. So now I've got all the angles filled in my triangle. So we have to find the distance from each observation point to the fire. And we're going to find the shortest distance from the fire to the road. Now the road is down here. So to find from observation point A to the fire, that would be side B, lowercase b. The road would be lowercase f. From point B to the fire would be lowercase a. So we have to find two sides of our triangle. We have to find side A. We have to find side B. And after we find side B, we have to find the shortest distance from the fire to the road. So we'll get back to that in just a second. To find side A, you've got to use the law of signs. We're going to have to use F because that's the given information that we have. So when I set up my law of sines, it's going to be side F over the sine of angle F. We know we're looking for side A over the sine of angle A. Cross multiply for side A, plug in the values to the law of sines, and then find that distance. Then to find side B, it's going to be F over the sine of angle F. We're looking for side B over the sine of angle B. Do the same thing again, solve it for B. This is all in the notes that I photocopied for you that's on Schoology. And then find side B. Once you do that, you have to find the shortest distance from the fire to the road. And what that's going to be is the distance, the perpendicular, well, it's called the altitude of the triangle. From F to the road, the shortest distance would be this perpendicular line. So let's say that we have side B. We've solved for side B. You've got that value on your calculator. What you can do at this point is you can redraw your triangle. So what we have, if I redraw my triangle, I should have used my ruler. I didn't. This is angle A. This is lowercase b. This is a right angle. We know the measure of angle A is 58 degrees. We know that lowercase b is the answer that we just found from finding side B, which again, you have to use the unrounded value on your calculator. So what you would do now is use right triangle trig. From angle A, this is the altitude of the triangle, the shortest distance from the fire to the road. That's the side that we're looking for. So if you switch to right triangle trig, the sine of 58 degrees is equal to opposite over hypotenuse. Sine of angle A is equal to opposite over hypotenuse. Fill that in, and then you will be able to find the shortest distance from the fire to the road. Now, looking at my notes, the way that I did it, I had kept side A on my calculator. I think you'll be able to figure it out. Let's go to the second example. Kind of a lot going on here, and again, I'm just going to lay out the examples for you, and then I'm going to expect you to go to the notes that I have posted on Schoology, run through all the mathematics. Don't just copy the notes. Make sure that you're thinking it through and that you're doing it yourselves. Okay, so now the second example, there's quite a bit going on here too. A road slopes at a 10-degree angle with the horizontal. So if we have this as our horizontal, and our road is going to slope at a 10-degree angle. Again, not used to using a whiteboard. Gotta say I'm kind of a fan of our smart boards that we have in school. All right, so this line is our horizontal. This is our road. The road slopes at a 10-degree angle with the horizontal. A vertical telephone pole stands by the road. When you think about a telephone pole on a hill or a road that goes downhill, the telephone pole is not going to be perpendicular to the road. It will be perpendicular to the horizontal. So this line that's going to be perpendicular to the horizontal will be our telephone pole. So this is our telephone pole. That's what we're going to look for the height of. So I'm going to mark that X already. When the angle of elevation of the sun is 62 degrees. Now your angle of elevation, guys, is always from the horizontal to the top of something. So what I'm going to do is I'm going to make this into a triangle. My angle of elevation to the top of the telephone pole, my 62-degree angle is going to go right there. So we really do have enough information now to fill in all the angles of this triangle. Oh, there's one more piece of information given. The telephone pole casts a 14.5-foot shadow downhill parallel to the road. So the 14.5 14.5-foot shadow, here's our shadow, is going to be right along there. Okay, let's finish filling in angles. So this is a right angle. This entire angle in here would be this 90 degrees and this 10 degrees. But using 180 degrees in this top triangle, if this is a 90-degree angle and this is a 62-degree angle, 180 minus 90 minus 62, this angle right up here will be a 28-degree angle. Now, if we look at this whole triangle, try to highlight it in red. We have this entire angle is 100 degrees. This angle up here is 28 degrees. 180 degrees in a triangle, minus 100 minus 28. The angle, the number of degrees in this angle down here is 52 degrees. So we have to find the height of the telephone pole. I'm going to redraw the triangle without the road and all that other information that's in there. But the triangle that we're going to use to do this will be this obtuse triangle. Here's the shadow, 14.5 feet. This was the 90 degrees and the 10 degrees, so this is 100 degrees. Using the top triangle, 180 minus 90 minus 62. The number of degrees up here is 28 degrees. And then this angle down here is 52 degrees. And we have to find the height of the telephone pole, which I'm going to put over here. So now that I've analyzed the question, finally, I can get to using the law of sines. You have to name your triangle. I'm going to call this side A, or this angle A, this angle B, and this angle C. What I'm looking for in my triangle would be lowercase a, and this side here would be lowercase b. So now go to the law of sines using A and B. So it'll be A over the sine of angle A. We know side B over the sine of angle B. Cross multiply for A, follow my notes and finish this question. Then the last question on the back, I think is pretty straightforward, but what you have to remember about this last question on the back, and then follow my notes, I think that you're going to be able to understand it. When you have this triangle, this question actually came off an Algebra 2 Trig Regents exam. It tells you right in the information that that angle R is an obtuse angle. I know it looks like a right angle. You can never assume that an angle is a right angle, but because it's an obtuse angle, it's going to be more than 90 degrees. This is not a right triangle, even though it looks like a right triangle. This side is 6 feet. This side over here is 10 feet. We have to find the distance from, this is P, this is Q. We have to find the distance from P to Q. So what we need to find in this question is lowercase r. This side over here is going to be lowercase p. This side up here is going to be lowercase q. Well, you can't directly find lowercase r. What you can find with the information that's given is the measure of angle P using the law of sines. So you would set it up as P over the sine of angle P. We know this angle is 30 degrees. We know angle Q, so it would be Q over the sine of angle Q. Solve this for the sine of P, find the measure of angle P. Once you find the measure of angle P, you can find the measure of angle R. So you would do 180 degrees in your triangle, minus the 30 degrees, minus the unrounded answer you found for angle P. That gives you angle R. Once you found angle R, then you can use the law of sines or the law of cosines to find side R. But always remember to use your unrounded values. So here's my second attempt at a video. I hope it was good for you guys. I'm going to try again. I'm going to figure out how to post this now, and hopefully this is going to be a good way to deliver instruction to you. So have a great day. I hope you're all staying healthy. I miss you all. Take care.